model exponents, like that number of inference rules are there. That inference rules you will apply and make a decision. It was more useful when complete knowledge was there, either 100% true or 100% false. But in the world, we are not getting everything 100% true and 100% false. If there is a query on whether there will be rain today in Chennai or Pondicherry, somebody will say that yes, somebody will say that no. We can probably say that there is a chance that in today in Chennai, there may be 80% chance that there will be rain in Pondicherry today. In this way, we apply probabilistic reasoning there. If you do that, that type of logic will be, example of higher order logic is fuzzy logic. So we have fuzzy logic, temporal logic, epistemic logic, many sorted logic, non-monotonic logic, like that. So many logics were developed in the AI. The aim of logics were to provide a mathematical foundation to the knowledge representation, to retrieve them using that. Based on this logic, query languages were developed. In databases, they developed the query language SQL based on relational algebra. Similar to that, a query language called DAplex was developed based on the Prolog programming language. The Prolog programming language, it is built with an built-in inference engine. There is no programming language other than Prolog that provides an inference engine. So that is the beauty of logics. Logics are handled by mathematicians. Now it is used by all people for doing inference. When semantic web was coming, the web which we are using are called syntactic based web. It is doing keyword search. If you give the correct keyword, you will be getting relevant information. If they are not relevant, you will be getting irrelevant information. That is why when you are searching for research papers from the Google, when I am searching, I am getting more relevant papers. If a new student is searching, he is not getting relevant papers. The reason is I know how to give the keyword. But the semantic web project, it is aiming at providing more relevant information by doing semantic analysis. In that, they are not using either first order logic or higher order logic. They are using description logic. In this way, the mathematical component of AI named logic was developed by many people. Some techniques like fuzzy logic, it is used in current intelligence techniques also. The first fruit of success from AI was expert systems. When AI was introduced, it was providing a very big hype. Later on, it was not achieved. It was a core subject in many universities in the beginning. It was pushed to elective. In many universities, even they dropped elective. And in many places, they started arguing that whether AI will be providing a success or not. Nobody knows that AI will become is able to learn the behavior, learn the environment, learn the data set, form the rules, apply the rules, and predict the future using past data and the current data. If you are able to predict the future, that itself is a very good type of learning. There are many knowledge representation techniques in AI. You can use simple database tables. You can use if-then rules. Semantic networks, it is in tree structure. Frames, tree structure with the properties. And the conceptual dependencies, it is language independent. And the extension of that is in script. Finally, ontology is the, I did not list out. Ontology is the latest knowledge representation technique. There are so many people who are using ontology right now. Search techniques are depth first, breadth first, hill climbing, genetic algorithm. It will provide the optimal solution, the best first, A star, AO star, minimax. Minimax algorithm, if you take, it is used for game playing. It has one minimizing play, one maximizing play. In the minimizing play, you will be trying to minimize the score. It is for the opponent. In the maximizing play, you will try to maximize the score. It is for you. We can take either chess playing game or cricket. I take the example of cricket. In the cricket, if you bowl, it is equivalent to minimizing play. You are trying to minimize the score of the opponent. When you do the batting, it is equivalent to maximizing play. You are trying to maximize the score of yours. In the same way, in chess playing game, when you are moving in such a way that you are maximizing the chance of your winning. And when the opponent is moving, you are seeing with respect to the minimizing perspective in such a way that if he makes this move, what type of mistake he is making and how we can minimize the chances of his winning. Like that, heuristic search algorithms are available in AI. They are all doing intelligent search. I told about logic. Logic is one component. In that, we have propositional logic and predicate logic. They manipulate true or false. In the situation logic, in addition to the arguments, we will be giving the situation with respect to location, with respect to time, or with respect to some other component. We will say in this situation, this is true. Fuzzy logic, instead of giving true or false, we will be giving qualitative words instead of quantitative. Qualitative word means instead of saying he has scored 590 out of 600, we can say that he got high marks. Similarly, if somebody is getting 100 marks out of 1000, we can say that low marks. So low mark, medium mark, high mark, height, tall person, short person, fat man, like that words are called linguistic words, or they are called qualitative words. In fuzzy logic, we use qualitative words instead of quantitative words. In temporal logic, we deal with time. So the time can be, we can do time comparison, whether one time is before another time or one time is after some other time, whether two time intervals are overlapping, like that we can do comparisons and make inference. In the non-monotonic logic, when you add new facts, the earlier conclusion will be changed. You may be having some evidence. With some evidence, you will come to some conclusion. When you add more evidence, the earlier conclusion will be changed. That type of reasoning is called monotonic reasoning, non-monotonic reasoning. In monotonic reasoning, if you add more facts, the earlier conclusions are not changed. In non-monotonic logic, if you add more facts, the earlier conclusions will be changed. Temporal logic, I have written 2 times. Okay. Now we will come to rule-based systems. Rules are represented in the form of if-then statements. In database systems, rules are called triggers. They will be having 3 components. One is called event, condition, and action. For example, event is disk full or mouse clicked, button pressed. Like that, event is taking place. Now you are checking the condition. If age is greater than so and so, then execute this procedure. Like that, you are using triggers in database systems for doing validation. We can do validation of age for an employee. If you want to do age validation, age of an employee may be between 18 and 65 or 18 and 60, 18 and 70, like that, or 20 and 70, like that. You can do validation. For that purpose, we are using rules. A rule-based system is a system which it applies the human-made rules for storing, sorting, and manipulating data, and so it mimics the human intelligence. I will tell what is meant by inference. Even though many are experts, I will give an example of inference. You are given the sentences, Pat is a man or woman, Pat is not a woman. If you store these 2 sentences in a database and give a query like select star from database table name, where name equal to Pat, it will display both Pat is a man or woman and Pat is not a woman. But If it is a artificial intelligence system, it will infer and say that is a man. How it is doing? It will use the propositional logic like this. It will represent Pat is a man as P, and Pat is a man as woman, as Pat is a woman as Q. Pat is a man or woman as P or Q. Pat is not a woman, that is not Q. Q and not Q cannot be true at the same time. Simultaneously, Q and not Q cannot be true. Therefore, we will eliminate Q and not Q. What is remaining is P. It is inferred that P is true. This is called resolution by refutation. In AI, we are doing resolution to make an inference. Such an inference is possible with logic. People were using the first order predicate logic, and they were writing many expert systems. Many intelligent systems were developed for all type of applications. First order logic was used, but later on it was criticized by some researchers, and they told that it is not expressive enough like English language. Suppose I want to talk to you in English, I can talk to you and in such a way that I can make a joke, I can make you to laugh, I can say a sad story, make somebody to cry, I can shout at somebody, they may be getting angry or they may be feeling sad. All this expressiveness is possible with the English. And more than that, if I am talking in Tamil, I may be doing better. Always our expression will be better in mother tongue. That is why whenever there is a fight between two people, they may start the fight with English and they may move to Tamil or their mother tongue. That time they will be getting more fluency since the expressiveness of that language is more for them. In that way, for me, if you take, I can do very well in Tamil, then English, then Hindi. I can go up to Malayalam, but Marathi and all I can understand only. I cannot express well. In this way, if you start writing something in logic, first order logic, it is not expressive enough. You cannot make somebody to understand the story which you are saying. Instead of that, you have to extend that logic with some other facilities so that it can handle incomplete knowledge, uncertain knowledge, vague knowledge, and inconsistent knowledge. The author who opposed and proposed the first logic was proposing the situation logic. In situation logic, he is giving the reasoning like this. Propositional logic and the predicate logic, they are using a static relation structure. That means if you have a table, student in bracket, student table with roll number, name, address, these are the fields, means student in bracket, roll number, name, address, that will be the schema. That static relation structure will be there up to the time you change the schema. But the current applications, they don't need a static structure. They want to store the knowledge about the changing universe of discourse. That means we have to add extra arguments. At least for situation he is adding. You see the relation structure given in this diagram. There are two blocks. Block B1 is on block B2. Now he is writing the predicate. On is a predicate. The arguments are B1, B2, and S1. On B1, B2 is predicate logic, but we are adding an extra argument called S1. It is called situation. By adding an extra argument called situation, we are saying that at situation S1, B1 is on B2. Now, B1 is removed, kept separately. After that, B1 is not on B2. It is happening due to the event of transferring B1 from B2. An event of transfer of B1 from B2 has happened. Now, not on B1, B2, S2 is true. Previously, on B1, B2 was true at S1, at situation S1. B1 was on B2 is true. At situation S2, B1 was not on situation not on B2 at situation S2. To to accelerator is okay, brakes are working. Like that, he is saying everything is okay. It was okay. Now it is situation S2, some time has elapsed. By that time, some naughty fellows who were playing near the car, they opened the air from the wheel. As a result of that, the air from the wheel went out. Now the tires are flat. At situation S2, the car conditions are not okay. Like this, situation logic can do reasoning. I will come to the fuzzy logic, that is another higher order logic. In crisp set, we are dealing with crisp set means first order proposition logic and predicate logic. We are dealing with true or false. That means either if I say that I am talking now, yes, true. I am sleeping now, it is false. Like that, you have to say either true or false in crisp set. But in fuzzy sets, it allows the gradation of truth values. It will say how much percentage. Now I am sleeping means how much percentage true is 0%. Similarly, I am presenting means 100% true. For this, you can use crisp set. But whether it will rain, whether the lines are not 100% true. We are preparing the lunch. Sometimes it will be fully tasty. Sometimes it will not be fully tasty. We can say that it is tasty by 70%. It is tasty by 80% and so on. There we are using fuzzy sets. We will see one example of a fuzzy sentence, fuzzy logic sentence. If a car which is offered for sale is cheap and old, then it is probably not in good shape. Here, the fuzzy words are cheap, old, good shape. The reason is cheap is a fuzzy word. For one person, cheap car is 5 lakhs rupees car is cheap. For other person, 20 lakhs car is very cheap. For other person, 1 crore rupees car is cheap. Similarly, old. For me, my car is new. It was purchased in 2013. It is 7 years old, but I say that it is new car. But for my friend, he purchased the car only 1 year back. He says that it is old car. The reason is he changes his car quite often. So old is a fuzzy term. Good shape. Good shape also. For somebody, something is good shape and the same shape is not good for somebody. These are all providing uncertainty, and we have common sense, incomplete knowledge. If you have common sense, we can understand, and with incomplete knowledge, we can understand the full thing. But for computers, they cannot understand with the incomplete knowledge. We have to provide with the full complete knowledge. Therefore, fuzzy logic was developed. In fuzzy logic, one procedure is called test score semantics. In the test score semantics, for every proposition, we will assign a meaning. Therefore, in test score semantics, a proposition consists of a collection of constraints. For example, you are having one English language sentence called Mary is brunette. Brunette means a woman with dark brown hair. Here the constraint is on the color of Mary's hair. That is, how many people are having dark brown hair? Whether Mary is having similar color with all other people, or her color is different, and whether she made it artificially or it is naturally. Like this, so many questions will come. In the propositional logic, we have to give only one answer, true or false. Next, most fat men are not very agile. Fat man means, if you think very fat man, he will not be able to run fast. He will not move very quickly. But in boxing and wrestling and all, we are able to see very fat man. They are also moving very quickly. That is why they say not all fat men most fat men are not very agile. Here the constraint is on the number of fat men who are agile. Now we will see how to give meaning to a procedure in test score semantics. First, you have to identify the variables and the constraints. The variables, one example is x1 is a variable. It indicates the color of Mary's hair, and the constraints are Mary is from this country, that is one constraint. Mary's age is this, that is another constraint. And Mary applies some costumes, that is another constraint. Like that, you have to identify the constraints, get score for each constraint. Then for every group of partial constraints, you get a score for partial test. After that, aggregate the partial results. Group results you are getting, aggregating them, and the whole result you will be getting. For example, you want to test whether the snow given by you is white or not. The proposition is usually snow is white is the proposition. Now you have a sample snow. For this sample snow, whether it is yellow in color or white in color, you want to check it. You are measuring the snow samples S1 to S7, and you are making a table called white table. In that, you are applying fuzzy logic and getting the degree of some fuzzy membership functions are available. With the membership function, you are getting the degree of whiteness. It may be 0.7, 0.8, like that you are taking. And for one group, you are getting the average alpha equal to sigma ti by n, that is the partial average. Like that, you will be getting partial average. Finally, you will be getting a overall average. After getting the overall average, you come to a global table. The global lookup table, suppose you are getting your average is 0.6. In your country, the snow was white by 60%. And you are checking with the global table. In the global table, it is equivalent to 20% only. Whether it is eyes color, even skin color, skin color of somebody in Tamil Nadu, if it is 100% white, it may be 80% white in some other place. Similarly, length, tall. The person who is 100% tall in Tamil Nadu may be 90% tall in some other place. That type of explanatory database is used, and using the global table, we will make a using the scores of local table and global table. One final decision will be taken. That will be the result produced by the inference engine. Now we will see the features of expert systems. To know the expert system, I will talk about domain expert. The domain expert is a person who is becoming an expert in one domain of research through years of training and experience. For example, a dentist is becoming an expert through a BDS degree and many years of practice. Similarly, we are becoming an expert with a PhD degree in computer science with many years of experience. The domain expert will be getting more experience and more expertise will be there. The knowledge engineer is a person who is developing an expert system. Knowledge engineering is a process of developing expert system. Knowledge means it combines facts and rules. Facts means any statement for which we can assign a truth value. And rules are given in the forms of if statement and if-then statements. The combination of facts and rule is called knowledge. A collection of knowledge is called knowledge base. A system which stores knowledge and retrieves knowledge efficiently is called knowledge-based systems. I compare database systems and knowledge-based systems. In database systems, more rules, and in knowledge-based systems, more rules. It will do inference. In database systems, only very few triggers. It will have more data. For example, you take the example of a railway timetable book. It is a database application. It has full of train timings. The book full of train timings. Very few rules like reservation rules and the cancellation rules are available in the book. But if you take the example of chess playing game, it has more rules, less facts. So in knowledge base, more rules, less facts. In database, less rules, more facts. In knowledge base, we are storing the rules and facts pertaining to a particular domain only. If you go from one domain to another domain, semantics analysis will be very difficult. For example, financial domain, if you say bank, it is financial bank. But in general terms, if you say bank, it may be financial bank or river bank. Similarly, in a database class, if you say table, people will understand that it is the table created by SQL statement. For it consists of rows and tables, rows and columns. But in general, if you say table, it can be multiplication table. It can be the table used by a teacher for a desk, chair and table, that table, or it can be a database table that we don't know. If you go for a particular domain only, semantic analysis is easy. Therefore, all intelligent systems like AI-based systems, knowledge-based systems, and all, they are working on particular domain. That is why its size is very small. They are able to keep both rules and facts together. Hence, we say that it is explicit. It is having explicit rules and explicit fact, and it is stored in the main memory itself. But in database system, the amount of data is more. It cannot be stored in the main memory. It is stored in the hard disk, and we are not storing the data and triggers together. Triggers are written, stored elsewhere, attached to a table. Whenever we are working on the table, the triggers will be triggered and it will do the validation. That is why we say explicit fact and implicit rules. Rules are not available in the table. Knowledge-based systems like medical diagnosis systems, it cannot be updated by clerk, since changing a medicine from one medicine to another medicine, it should be done only by a doctor. It cannot be updated by a clerk. In database systems, updates are made by clerk. These are all the difference between database systems and knowledge-based systems. I will compare expert systems, knowledge-based systems, AI programs, and computer programs. All computer programs are not AI programs, but all AI programs are computer programs. AI programs exhibit intelligent behavior by applying heuristic search. In the heuristic search, they will be going for the least cost and optimal method. In knowledge-based system, it is a AI program, but it separates the domain knowledge and problem-solving knowledge. If it is a expert system is a knowledge-based system in which we are consulting a domain expert and make the system. Suppose you are a knowledge engineer, you are writing your own knowledge-based system. It is called knowledge-based system. When you are writing and you are putting the rules based on the domain expert's knowledge, then such a knowledge-based system is called expert system. The expert system, it has two important components. One is called knowledge base and inference engine. Any computing system, it will have one input, process, output. That's all. Computer means you are giving an input, it is processed, it is giving output. In expert system also, there will be a user interface to take the input and inference engine to do the process, and an output or input output for knowledge base. The knowledge base will be having the storing the results, or it has rules and facts as for providing input. In this way, if input is coming from knowledge base, output is also going for knowledge base. Only two components. One is knowledge base, another is inference engine. You can have a direct connection between the knowledge base and inference engine. It will perform inference. It is called a deduction. It can do reasoning with respect to time, with respect to comparison, and it applies either in forward chaining or backward chaining. In the forward chaining, we apply the rules one by one and come to the goal. But in backward chaining, we start with what we want to get, our goal. We start with the goal. To get the goal, what rules are necessary, we decide, apply that rules in forward chaining direction. And in expert system also, knowledge representation and manipulation is important. I am showing a small expert system. You see the first rule, it is for classifying the animals. The first rule is, if X has hair, then X is a mammal. If X gives milk, then X is a mammal. Like that, first rule only, X has hair, it is a mammal. Now we are having a fact, stretch has hair. For X, we will substitute stretch. If X has hair, X is a mammal. If X equal to stretch, now stretch has hair, therefore stretch is a mammal. We know that stretch is a mammal. After that, we are coming to rule number 8, let us say. In the rule number 8, if X is a mammal and X chews cud, then X is an ungulate. That is a rule. Now we come to the fact. In the fact, we have stretch chews cud. When we have stretch chews cud, we know that already stretch is a mammal. If something is a mammal and chews cud, it is called ungulate. Stretch is a mammal, stretch chews cud, therefore stretch is an ungulate. Now let us come to stretch once again. Stretch is a hare, it is a mammal. Stretch chews cud, it is ungulate. After that, it has long leg, long neck, tawny color, dark spot. If you take this rule number 11, if something is an ungulate and it has long leg, long neck, tawny color, dark spot, it is a giraffe. Therefore, we can conclude that stretch is a giraffe. The whole inference process is done in an expert system using forward chaining in this way. Figure 9 shows an example of an inference using forward chaining in expert system. It starts with, it has hair, stretch is a hare, and it is a mammal. Now it chooses cud. These two inputs are given to AND gate. It is deciding that it is an ungulate. Now ungulate is one input, long leg, long neck, tawny color, dark spot. These are all inputs. The output is, it is a giraffe. Like this, we can infer that whether some animal, given animal, is a cheetah or not. In this way, the intelligent systems are providing inference. Whether you are using a machine learning or any type of intelligent system, in all the intelligent system, what is important is how you are forming the rules. In neural network also, you are forming the rules through training. In expert system, we are giving man-made rule, or through inference it can add more rules. That means you are making decisions based on the facts and rules. That is why I was introducing the principles of AI. The principles of AI as it is used in machine learning. The machine learning is a study of algorithms and computer models used by machines in order to perform a given task. It is a subset of artificial intelligence. Therefore, it can learn. In artificial intelligence, learning is also one component. They wanted to teach the computer about ball. If you want to teach a ball to a child, you can show a volleyball and say that it is a ball. You can show one football, you can say that it is a ball. After training with the volleyball, football, you show a cricket ball, ask the child what is this. She may be recognizing, may not be recognizing. If she is not recognizing, you have to change the ball size to cricket ball, tennis ball, give training to the child with the different colors, with the different sizes of the ball. Then she will be learning what is a ball. Similar thing only in machine learning also, we are training the computer with so many examples. When we give examples, sample data set, the sample data from data set, when we are training, it is understanding, forming rules. That rules will be applied for making conclusions during the testing. That is done in machine learning. Deep learning and machine learning also similar. In deep learning also, we are using neural network with increased number of hidden layers. But one benefit of deep learning is you need not give labels also, it will learn. That is why it can be unsupervised also. The data can be structured, it can be unstructured, it can be semi-structured. The deep learning or deep neural network is a subset of machine learning which uses neural network to analyze different factors with a structure that is similar to the human neural system. Now, the learning can be either supervised learning or unsupervised learning. In the supervised learning, we will give some examples. Using these examples, we say labels. Using these labels, the algorithm will understand the category. You will be classifying into either this category or that category. The categories will be understood by the labels which we are giving. In unsupervised learning, like clustering, K means clustering and all, we are not providing label. We will say how many clusters we will make. It will form so many clusters based on some distance formula. The simplest type of learning is knowledge acquisition. You can go to the expert, you can ask him to provide the knowledge. If he is able to provide the knowledge, that is called knowledge acquisition. Rote learning means learning by bygoting. Our ancestors, they made us to do rote learning only. Up to 10th, we are doing rote learning by multiplication table. If you are asking me whether it is 16 16s are 256, 14 40s are 196, 13 30s are 169, anything you can ask me. Up to square root table, up to 25 are 625, that I did rote learning, I am able to do very easily. That is one type of learning. After that, learning by examples, learning ball with the examples I have explained already. Similarly, transfer of learning. If you do learning in one area, that can be transferred to another area. When I learned cycling, it was transferred to learning the two-wheeler. When I learned two-wheeler without gear, the same techniques I applied when I was driving the two-wheeler with the gear, but with the additions. Similarly, when I was driving the four-wheeler, some principles from the two-wheeler like clutch, etc., brake, etc., accelerator, they were all coming from two-wheeler also. In this way, we can do transfer of learning. Now, knowledge acquisition, you can start with a knowledge engineer. He can go to the domain expert. He can ask for some doubts. The domain expert will provide knowledge in terms of concepts and solutions. You can ask some more questions. The domain experts will give some more answer. You collect the knowledge, formalize them, store in a knowledge base. If you want to develop a medical expert system, go to a senior doctor, get the knowledge and make a knowledge base. You can collect it from so many other sources like textbook, report, etc. But how the inference is taking place or experts are solving the problem is, for example, you have rules like A tends to D, E tends to G, D implies E with the past experience. Now you are giving situation A and the expert knows that if A then D. So he comes to the situation D. Now you are saying that right now D and he applies the rule D implies E. He comes to E. Now you say that situation E. He knows that E tends to G. G is the goal. Like whether the fever is malaria or dengue or some other fever, if it is a known type of disease, the experts will be deciding like this. If it is an unknown situation, they will apply the general principles. They know for any type of fever, this is the medicine. But for this type of fever, there is no medicine. Let me apply the general principles and try to do a treatment. For example, you are giving situation 1 and they apply general principles, they come to situation 2. Then they apply general principles from situation 2 to 3, 3 to 4, and 4 may be a novel solution. In this way, you are making inference. You can collect knowledge from a domain expert by sitting with him or by any other learning. Now, neural network, everybody will be knowing it consists of one input unit, one output unit, one processing unit, and in this diagram, it has dendrites for taking input, soma for processing the input processing, after that axon for output. Yeah, neuron is a fundamental processing element of a human brain. A human brain has 100 million neurons, an ant has 250,000 neurons. The collection of neurons will make a classification system or inference system. Now, the neural network is a set of connected models. I will show the example for a neural network. It is a combination of many inputs. We have inputs like x0, x1, etc. And every input is having some weight. You are multiplying the weights with the input and doing a summation. That summation is called V. V equal to sigma j equal to 0 to m wj. Now, that one you are giving to a function called activation function. Y equal to f of x equal to 0 when x is less than 0.5. If it is greater than 0.5, it is 1. Like that, if you define a function, if you give the input x equal to 0.55, now x is greater than 0.5. When x is greater than or equal to 0.5, its value is 1. Therefore, it will be put into the class 1. Suppose you are giving the input x equal to 0.45, it is f of x equal to 0, you are putting into a class 0. So, two-way classification problem, either true or false, you can do with a neural network. Now, the equation for straight line for x1 equal to x2 will be going from origin. But if you want to push, you are adding a constant. B can be positive, means it will come here in the positive direction, or it will be coming to the negative direction. That is called bias function. That bias function, if you add, you will be getting the activation function like this, y equal to pi of u plus b. Now, this is the neural network. The neural network, it has a set of inputs. The inputs are coming as xi. Now, the xi's are the inputs. The inputs are given to the nodes. The neural network consists of nodes and links. Now, the nodes are getting the inputs from ith layer of the ith component. They are called xi. If the weights are denoted for I to j, it is called wij. Similarly, if the weights are coming from j to k, the weights are called wjk. Now, the output of jth layer will be called oj. The output of kth layer, it is called ok. This is called a two-layer neural feed forward neural network. That means it comes from bottom, goes up, the top only output. The first bottommost circles are called input layer, and the next layer is hidden layer. There hidden nodes are available. The last layer is output layer. This is a two-layer neural network. If there is more than one type of hidden layer, then it will be called multi-layer. Suppose there are two hidden layers, it will be having 3 layers, totally 3 layers. This way, we are developing a neural network. Now, the neural network will be combination of input vector, weight vector, summation, bias function, then activation function. After that, you will be getting a output. For overall, you will be using this model only. First, you are getting the input. In the input, xi you are giving, and what you are doing is, you are doing the summation of wij plus input from y with the bias function you are adding, that you are getting as output. And for example, for this one, input is coming from here, input is coming from this, 2 inputs this is getting, the leftmost. So for this input and weight, this input and weight, you will be adding them. Like that, for every node, you will be calculating that. Next, the activation function, it is called a sigmoidal function. It is defined here. That one you will be using to get the y value. If you are willing to reduce the error, you will be using the error functions like this. Now, the error functions will be minimizing the error. After minimizing the error, for back propagation, you will be adjusting the weight using the formulas given here. In this way, the neural network is adjusting the weight. Another thing is genetic algorithm. In the genetic algorithm, we will be doing crossover and mutation. I will show what is crossover and mutation. There are 2 parents. In the 2 parents, if you make two children from the first parent, first part, and the second parent, second part, if you take 101, 0011, this is one child. Then parent to first part and the parent to second part, if you take, you are getting next child 110, 0111. That is called crossover operation. If you change the 1 to 0 and 0 to 1, it is called mutation. Now, the genetic algorithms will be working like this. First, you have to start with a random population. Here also, the activation function, it is called the fitness function. The fitness function, if two parents are there, they are making different children, and among the children, the best children will be surviving. For that, we will apply the fitness function. Survival of the fitness will be taken by the fitness function. You are creating new population by following the algorithm. You will do the selection of two parents, do crossover and mutation. After that, apply the fitness function. You will accept if they are fit. Otherwise, you will go to the further run. Like that, you are proceeding. This is the flow chart, and I will take an example of knapsack problem. In the knapsack problem, we are going to say that representation in zeros and ones. If you take this example, we are having three solutions. In the solution 1, we have 7 kilo weight, 5 benefit, but it is not considered. 8 kilo weight, in the flight you are going to take, you are allowed to take only 25 kilos in the flight. Like that, some rules will be there, but you have to take very costly items in such a way that you are getting more benefit. For that, the benefit is also given by numbers, weight 8 and benefit 8. Like that, wherever ones are there, you see here one is there in 2, 4 and 6. That one, if you are adding the weights, the weights are 8 plus 10 plus 6. Similarly, you are adding the benefits 8 plus 2 plus 9, the 24 kilo with the 19 benefit. Next, 19 kilo with the 20 benefit. The last solution is 22 kilo, but benefit is 20. More benefit with less kilo. This is the best solution. This type of solution can be done with the genetic algorithm. So that is also another example of computational intelligence. I want to conclude. I started with artificial intelligence. In that, I talked about knowledge representation and reasoning. Then I went to machine learning. I introduced neural network and genetic algorithms. But we have anti-colony optimization. It will be answer searching for food, and they are forming a line. They find the shortest path. All the other runs will be going in that shortest path. In the same way, network routing, if you want to apply, you can find the shortest path like by applying anti-colony optimization. They will be also having a probability function like activation function. They will be putting pheromones. With that, you will be learning the behavior of ants. Based on that, the traffic behavior will be learned, and you can find the shortest path. Similar to that, we can do the behavior of birds. By seeing the behavior of birds, you can do the optimal solutions for some problems. Then fuzzy systems. These are all the components of computational intelligence. This is my talk. I thank you. Thanks. I'm ready to answer your queries. You can ask me queries.
Thank you, sir. Thank you, sir.
Yes, madam.
Participants, if you have any queries, you can either ask sir or you can post in the chat box.
Madam, not hearing. Tell me, madam.
Hello, sir. Can you hear me, sir?
No. Now only we could able to hear it. Yes.
Okay, sir. Okay, sir.
Okay.
So I thank all the participants for patiently listening. Thank you.
Thank you very much, sir. On behalf
Yes, sir. Thank you, sir.
Sir,
of also,
Sir, shall I conclude, sir? Shall I conclude, sir?
Yes, madam.
Okay, sir. So on behalf of the coordinators and participants, I would like to thank our distinguished speaker, Dr. A. Kannan, for making this session interesting and meaningful. Professor has given a complete insight on computational intelligence techniques. He has explained on the first order logic predicates and situation logic, fuzzy logic with good examples. He has given a complete understanding of knowledge-based system, expert system, machine learning, deep learning, and mainly with a good insight into neural network and genetic algorithm. Thank you, sir. Once again, I thank you for sharing your knowledge with us and being with us for this international conference, as a part of the international conference. Thank you, sir. Thank you so much, sir.
Thank you, madam.
Thank you, sir.
Yes, sir. Thank you, sir.
So we can close the, thank you.
Okay, sir.
Participants can fill the